So hello guys, what's up? We are back again with another question from our DSA challenge series. So let's get started. So guys, today our question is LRU cache, in which we are given some keys and some values, and we need to put it as well as get it according to some rules. Okay. So let's understand it a bit. So we have a capacity, that is the number of keys which can be there in the cache, and then there will be a function known as int get, which will have key as a parameter, and we need to return the value of the key if the key exists, otherwise we will return -1. And nextly we will have a function put, which will have both keys and values. Now what we have to do, we have to return we have to update the value of the key present if it is already present. If it is not present, then we have to add it, or else if the capacity is full, then we have to remove the least recently used key and then update the given value with the key. So let's see how we can do that. So we can do this, and lastly we have to implement these functions in O of 1 average time complexity. So what we can do is we can have a doubly linked list and a hash map to implement this. Now, why only linked list? See, linked list insertion and deletions can be done in constant times, and using hash map we can map the values very easily. So that's why we are using. Also, we will be using doubly linked list so that we can traverse to previous pointers as well. From Okay, so next we have by default in general linked list, and we will also have previous pointer so that we can travel from the node to its previous node. Now, what will the map do? Map will store the address of the key. Okay, so map will have a key. Okay, let's see here. Let's see from the starting the code. We will create a cache node class, which is nothing but a doubly linked list with two values, identifier, which is a key, and the value. Okay, so and what we will have next, we will have a map. So map will have a mapping from int to the cache node, that is the address. So int will store the key, and the address of the node in that particular key we will have in the map. We will have variable capacity and the current size, so that we can check whether we are exceeding the capacity or not. Now let's move directly into the code. So what first we need to do, we need to implement the get function. Okay, so get function is really very simple. We will find the key in the map. If we will not find it in the map, we will simply return -1. Now, if we find it, we will return the current node value, but we need to do one more thing. That is, it was the recently used key. So we need to move it to the latest. Now, what logic we will use is, we will have all the latest keys at the end. Okay. And we will have all the least used keys at the starting of the linked list, so that we can differentiate between the two. Okay, so let's see the move to latest function very quickly. Yeah, so this is move to latest function. This is nothing but essentially we are inserting at end of the linked list. That's it. So if the node is the newest node, then no need to do nothing. We can simply return. If it is the oldest, then also we will insert it at end. So oldest will become nodes next. So we will insert it that way. And yeah, nodes previous is equals to newest, and nodes next is equals to null pointer. That clearly means we are indicating it. We are inserting it at the end. Now, if newest exists, that means there is still a node. The newest next is equals to node, and then we will update, of course, the newest. Newest is equals to node. And if none of the node exists, then we have to do oldest is equals to node and newest is equals to node, since this was the single node we had. Okay, so in this way, the basic idea is to insert the node to the end of the linked list. These are some of the edge cases which we can handle. Okay, so this was the get function. Now let's see the put function. Input function, first of all, we will check if the key exists in the map or not. Now, if the key exists in the map, what we will do, we will simply update its value as given in the question. We have to update the value and then we will move it to the latest. So move to latest function we have already seen. Else, if the key does not exist, then we will first check whether the capacity is there to handle it or not. So if there is if the capacity is over, then we will evict the oldest node. We will see the function, or else we will simply add to the latest. Add to latest or move to latest, what is the difference? The nothing much difference, but add to latest, we are creating the new node and then adding it. Okay, so evict oldest node, let's see the code. Okay, yeah, evict oldest is nothing but what we are doing, we are simply removing from the head. Okay, so we are storing the oldest next node as temp, and then we will erase the value from the map, and then we will simply delete the oldest. Now if the temp is not null, okay, so just a second. So if the temp is null, then we will simply point oldest and newest to the null pointer, and else we will point oldest to the temp and oldest previous as null pointer, and we will decrement the size. So essentially we are decrementing it from the head. So yeah, guys, this was all from this question. Just in case you understood the question, you liked the video. Thank you so much, guys. Make sure you hit the subscribe button, press the like button, and share it with your friends. Thank you so much. We shall see you next time.